Here we have a SAT math question. Okay, let's go with the information. Triangle ABC is inscribed in a circle with a radius of 85. The length of AC is 170 and the length of BC is 168. What is the value of AB over BC? Okay, so triangle ABC is inscribed in a circle and the radius of the circle is given, that is 85. And in this triangle ABC, which has been inscribed in the circle, so the length of the side AC is given, that is 170, and the length of the side BC is also given, that is 168. They are asking us to find the ratio between the length of AB and BC. So we know the length of BC, that is 168. So we have to be knowing the length of AB. So once we get the length of AB, we can find the value of AB over BC. Okay, here we have to notice an important information in this question. So the radius of the circle is 85 and the length of the side AC of the triangle is 170. So this 170 is exactly 2 times of the radius. Since this 170 is exactly 2 times of the radius, so this AC represents the diameter of the circle. Okay, now let me draw the picture for the given information. So first let me draw a circle over here. And so from the given information, it is very clear. The side AC of the triangle represents the diameter of the circle, because the length of AC, that is 170, is exactly 2 times of the radius. Okay, now let me draw the diameter AC first. So here I've drawn the diameter AC. Let me mark it over here, A, and here we have C. And also let me mark the third vertex of the triangle, that is B, over here. Now let me connect AB and BC over here, AB and BC. Okay, now we have the length of AC, that is also diameter, that is 170, and the length of BC is also given in the question, that is 168. Okay, so now our aim is to get the length of AB. Once we get the length of the side AB of the triangle, we'll be able to get the value of this fraction AB over BC. Okay, now let's consider the arc ABC. Actually, this arc ABC is a semicircle. So because whenever an arc is intercepted by the diameter of the circle is a semicircle, and the angle formed at any point on the semicircle by the diameter is a right angle. So here let's consider the angle measure at the point B on the semicircle. Actually, this angle is formed by the diameter AC. Since the angle at point B on the semicircle is formed by the diameter AC, then the angle measured at the vertex B has to be right angle. So now clearly ABC is a right triangle. In this right triangle, I know the length of one of the legs, that is BC, and this AC is the hypotenuse of the triangle because it's opposite to right angle. So using Pythagorean theorem, I can get the length of the other leg AB. Okay, now let me use Pythagorean theorem. Pythagorean theorem says that the sum of the squares of 2 legs of a right triangle equals to square of the hypotenuse. That is, first let me square the leg AB, that is AB square, positive. Then let me square the second leg, that is BC, BC square, equals to the square of the hypotenuse, which is AC square. Okay, here I do not know the length of AB. That is what actually I have to find. So I'll keep this AB as it is. And for BC, I know the length is 168. So let me plug in 168 for BC, then it will become 168 square. And for AC also, we know the length is 170. We can plug in 170 for AC, then we get 170 square. Then I'm getting AB whole square equals to, so the evaluation of this 168 square is, sorry, it's not equal to, it has to be positive. So the evaluation of this 168 square is 28,224. And the evaluation of this 170 square is 28,900. Okay, since our aim is to get the length of AB, we have to isolate AB. So for that, let me get rid of this value. For that, let me subtract 28,224 from both sides. Let me do it. So this one will cancel. I'm getting AB square on the left side. So when I subtract 28,224 from 28,900, I'm getting 676. Okay, now let me square both sides to get up the square over here. Then here square root and square root cancel. So whenever I take square root on both sides of the equation, for one of the square roots, I have to consider positive and negative sign. Usually we consider positive and negative sign for the square root which contains number inside. So this square root contains number 676 inside. So for this square root, we can consider positive and negative sign. We have AB on the left side, then we get AB equals to positive and negative. So when I evaluate the square root of 676, I'm getting 26. So the length of, AB equals to either positive 26 or negative 26. But AB is one of the sides of the triangle. So one of the sides of the triangle can now be a negative value. So we can reject negative 26. So we can consider the positive 26 for AB. Okay, now I got the length of AB. Our aim is to find the value of the fraction AB over BC. Let me write it, AB over BC. which is equal to, so the length of AB is 26 and the length of BC is already known as it's 168. It's given in the question itself. So the greatest common divisor for this 26 and 168 is just 2. So when 2 goes into 26 13 times and 2 goes into 168 84 times. So we get AB over BC equals to 13 over 84. Okay, now what I can do is like I can leave this 13 over 84 as a value for AB or BC. Otherwise, I can divide 13 by 84 and get it as decimal. So when I divide 13 over 84, I'm getting a long decimal. When I round it to the nearest hundredth, so it's approximately equal to 0.15. So the value of AB or BC is 13 over 84, or the approximate value of AB or BC is 0.15.